So far, we've learned how to find the derivative of power functions and e to the x. And other than that, we've learned some rules for combinations of functions, right? Like the sum of two functions, the difference, a constant multiple of a function, or a product of two functions and the quotient of two functions, right? So we've learned some rules, product rule, quotient rule. Um, and the next major classification of functions that we're going to learn derivatives for are the trigonometric functions, right? Sine, cosine, tangent, and so on. So first thing I want to do is take a look at the derivative of sine of x. Now, I'm not going to do this any kind of rigorous proof. What I want to do is just show you conceptually how what the derivative of the sine of x is. And we're just going to do that by, here we have the graph of sine of x, and we can sketch a graph of the derivative just by looking at the slopes at different points, right? We know that the slope of the function is at any point is its derivative, and so we're just going to sketch the general shape of the function using the slopes like we did at the beginning of chapter 3. So let's take a look at this. We have sine of x. We have it graphed between negative 2 pi and 2 pi. And let's just start by, remember when we did this in like, I think it was 3.2? We looked at the slopes. And I think probably the best place to start is look for where the slope would be 0. Because those are easy to spot, because that's where the function is going from a positive slope to a negative slope, or negative slope to a positive slope, right? It's changing, the slope is changing sign, and so it has to pass through 0 if it's continuous. And so you see up here, the graph is changing direction, and so here the slope, we'll call it dy dx, right, is equal to 0. All right, so I probably would start at those spots, right? You have another one down here where the slope is changing from negative to positive. So the, let's see, getting kind of close to the bottom here, dy dx is equal to 0 again, right? The slope of a tangent line would be, or a tangent line would be horizontal, right? So the slope is 0. Okay, we have another one over here, right? And another one here where the slope of a tangent line would be 0. So we can plot where those zeros here are. It looks like it's, halfway between negative pi over 2 and negative pi, right? And then we have another 0 here. So that's got to be pi over 2. Sorry, negative pi over 2. This would be pi over 2, and this would be 3 pi over 2, right? So we have the zeros graphed. And then from there we can look at where is the slope positive and where is it negative. Okay, so look, if we just look here in the first quadrant here, we've got dy dx is greater than 0, right? If I draw a tangent line anywhere on this portion of the curve over here, it has a positive slope, right? So it has to be positive, and it's positive down here as well. So between, this would be minus pi over 2 and pi over 2, the slope is positive, right? So the graph of the derivative has to be positive. All right, so I've sketched that positive portion of the derivative there. And so now if we come over here, if we look at tangent line, anywhere between pi over 2 and this would be 3 pi over 2, it looks like the slope is negative. So for that portion of the curve, that portion of the derivative is going to be negative. Okay, so I've sketched that in. And I'm just going to do that for the other parts of the curve and sketch the rest of this in. All right, so I've sketched the graph of the derivative given the graph of sine of x. And that should look familiar to you, right? That should look familiar. Right, it's starting at 1 and coming down and back up. It's a periodic function. And It starts at 1 and comes down. So you can see that this looks like a cosine function, right? Now, that's kind of a, that's not really a rigorous proof of the fact that, of the derivative of sine of x, but it's meant to give you sort of an intuitive sense of why it is. Now, there's a more rigorous proof in your book, and if you want to go through it, you certainly can. You can look at this section in the book, and they have a more rigorous proof. But the end result is that the derivative dx of sine of x is cosine of x. Okay, so once we've established that, then we can just use that. All right, I'll meet you in the next video for the cosine, the derivative of cosine.